Okay, so let's have a look at the first mini IA. So what we're looking at is an investigation into Apollonius's method for tangent lines. So this is from Apollonius, a Greek mathematician who you can see here, born 262 BC, died 190 BC. So this is over 2,000 years ago. He came up with this method for calculating tangent lines. Now the difficulty in calculating a tangent line. Firstly, a tangent line. So if we take this curve that we see f, we can see the curve y equals f of x. It's a parabola. They understood the parabolas from the conic sections quite well. They didn't have the coordinate axes that we have here, and the main thing is they don't have calculus, so we can't use calculus on this one. So what you needed to do is calculate a tangent line. Now, a tangent line is a line that touches a curve once and only once. It touches the curve once and only once. If you draw most lines through this, you just pull up a bit of a pen. If you draw, actually it's hard to do, if I draw it slightly to the right like this, it will cut the curve in 2 points like this. This is a secant line. This is a secant line. We need to draw a line which touches the curve only once. And what's really interesting about this is that a tangent line will have the same gradient as the curve at that point. So the gradient of the tangent line will be going up at such a rate that at the curve where it's touching, the two of them have exact. Let me switch that on. So here at this little point, the two of them, here at this point here, the two of them are going up at exactly the same rate. So they have the same gradient. And this is a technique that allows us to find the gradient of a curve at any point. You guys know how to find the gradient of a line, and that's constant throughout. But a curve doesn't have the same gradient all the way through. So this is the fundamental basis for calculus, the whole field of calculus, which is invented around about 1500 AD. So it comes much, much later. It comes about 1700 years after this technique that they actually develop a technique that allows us to find the gradient of the curve. So the tangent line gives us the gradient of the curve. What your investigation requires is that you're going to use Apollonius's method to show that it works. So that's fine. Firstly, what you're going to do is you're going to follow Apollonius's method through and use your analytical geometry techniques to calculate the equation of the tangent line using his technique. You have to use his technique. You can't just use any technique that works. Don't research it necessarily on the internet. Follow the instructions. Use his technique to show that it works here. And then you need to show that his technique works for any point. So then you do an algebra. It's like a proof. So you'll do it in general terms. Let me show you it working. So let me show you it working. I'll draw it. So to show that it works, we can sketch it. So I'm going to use GeoGebra a little bit here for you to create the diagrams. So what you need to do is the skills that you're going to get assessed on is not necessarily solving the problem. It's showing how you solve the problem. So the two main things you need to show your skills on is the use of the equation editor in Google Docs, and the ability to construct a document that is well formatted with diagrams to support your necessary case. You have to produce the diagrams in some software. I'm suggesting GeoGebra. You screenshot it, you copy and paste it in. You have to do a few of the formatting techniques that I'll explain during this video. And those are the two main skills assessed. As you do that, you have to be conducting some kind of math. So the math is secondary in a way to the overall assignment here today. So I'm going to firstly pull up my A. So I'm going to give A an increment of 0. Sorry, let me get my glasses on. 0.25. Is that a decimal point? Yeah. That's going to be my gradient. I'll just use another slider over here. Give it a gradient of 1. Sorry, an increment of 1. And I will call this one K. So, like that. So this is the point of tangency, so I can move it around. So looking back at here, A is the letter here, which is the coefficient of the parabola, and k is going to be the x coordinate of p, and I can move k and the point p will move around. So now we need to draw the function. So firstly, I'll say y equals a times x squared, and there's our parabola. We need to put in now the point of tangency that we're going to use, which was called point P. So we put in point P. P is going to equal, and I'm going to have it at k comma f of k. So this will give us a point on the curve. I've done it this way with the k constant over here. Lets us move the point around. You can see it moving around on the curve. So now we need to find the point Q over here. So the point Q has the same y value as P does. The point Q has the same y value as P does. So I can put this in and say Q is equal to 0 comma f of k as well. That's it has the same. We need a little, in the diagram, we need a little line segment between these 2 points, like that. And then if I click here on the settings, you see me clicking here on the settings, I can choose the style of line, make it a dashed line like this one. Yeah, forget the dashed line up there. So the way Apollonius' method works is we need to, so he would do it by, they would draw the parabola, find the point, they would draw this line across horizontal using compasses and things to make it a horizontal line. So it's horizontal to this one, so when they were drawing. They're not actually got any coordinate axes when they're doing this. They're not using coordinate plane. They're just drawing the parabola using from a conic section. They're then working on probably, typically if they wanted to show it, they could do it on parchment, but if they're just explaining it to students, they're doing it in the sand. So a classroom in this particular period would have a bunch of boys around. So boys with the education on this one, they would be on the little steps around in a tiny little amphitheater about the size of a classroom. In the center of the classroom is a large sand pit, and then the master would explain things with a big stick in the sand. We had a couple of slaves who would brush the sand clean, to wipe the board clean, and think this is how it looked. This is how it looked into that period, a math classroom. Yes. So he's drawing it in the sand, and so they can use compasses if they're doing it more accurately. If they're working on parchment, that's really expensive. Next up, we need to put in the point R. So the point R is going to have the same length. So you can, the way that they would do that is you would take a pair of compasses, you put it here at the origin, you put the other compass here at Q, then you would spin the compass around it to this point, and then it's going down there. But we can use the coordinate axes for that. And this point R is going to be at 0 comma minus f of k. So they would actually use a compass and just spin that point around and use construction to show that it works. So we've got our points drawn. We need our tangent line. So our tangent line, according to Apollonius' method, is quite simply from taking that point there to this point here. And what we should see here on the diagram is that this touches this line only once here at this point. Now I can show that to be true in a way because this software will let me draw a tangent line. I can draw a tangent line here with this tool here. I can click on the curve and I can click on the point P and it will draw the tangent line. Now if we look at the two lines that have been drawn down here, here at this point and here at this point, we see that they're exactly the same line. If you divide this one through by 2, you'll see you'll get that one. You can see here in the algebra that the two equations are the same equation, which means it works. So a diagram like this, nicely formatted, is going to help you in your assignment. So what you might do is you might screenshot something like this one, print this. Okay, when it comes to diagrams, you are not allowed to screenshot this diagram from my notes. You have to make your own diagram. Part of the main point in the assignment. Don't screenshot that and stick it in. You have to make your own diagram using a software like this one. You've got a video of me showing you how to do it, basically. And then you're going to stick it into Google Docs at some point. What I would recommend when you're working in Google Docs and you're putting in diagrams like this one, So we're going to have our title here like this. We're going to have our subheading. We're going to have an introduction. Then we're going to have our example at 2, 4. We're going to talk a little bit, and then you need to stick in your diagram. So when it comes to sticking in your diagram, you want to insert a table. So insert table. I want like a 2 by 2 table like this one. Need to go over to some kind of a editing tool like this one. This isn't a great diagram. I haven't got my axes quite right. But yeah, let's go for this. Something like that. Crop it. Stick it in here. Resize it to the size I want. Every diagram, every graph, every table must have a heading. Every table, diagram, graph must have a heading. It must also be numbered. So, as an example, graph 1 typically start like that, and then say something descriptive. Diagram showing Apollonius's method at 2, 4 or something like that. Then select your table and format it a little bit more. We'll take away the table border like that. I can then control this and resize it as necessary right around it. Let me zoom out a little bit. Zoom, there it is, zoom. You see, so then it's going to be nicely formatted on your table as necessary. Next up, we're going to have to do some equation editing. We're going to have to present some math. So this is the second main important part of this assignment, is to be able to write math. So if I want to write math, all math that you write, every number, every equation, every formula, every coordinate point must be written in the equation editor. Every single one must be written in the equation editor for it to be nicely formatted. So you click Insert Equation here. I overdid it. Didn't I press it? So Insert Equation. It pops up this equation editing tool. So when we want to come in, we want to show something. Let's say we want to have our coordinate point. We click here on the selection of tools that you can find. Always use a bracket from this. So if we want to have 2, 4, we write it in like this in the equation editor. Let me explain and show why your bracket should always be like this. So I'll insert another equation, and I'll use brackets from the keyboard this time. 2, 4. Looks okay. So now let's go to this equation, and I do other calculations, and I need to add a fraction. So if I add a fraction like this one, let's say this becomes 4/3 or something. And then I go to this one and I insert some fraction. This becomes 4/3. See how the brackets from the equation editor grow to fit correctly, and see how the brackets from the keyboard do not. So only use from brackets from the equation editor. We show some other tools that we might want to use. This is just going to be gibberish math now. So you can see here, this is a lot of the great tools that we're going to need. You can find a lot of things that you want. You need the hat symbol for like a linear regression. You don't need it for this, or the mean, x bar. You can find those features here. You can find exponents. We do need this one. So this one is, maybe we want x squared like this. We can format the x squared correctly. Any other bits and pieces? You'll find the Greek letters that will help you. You'll find the correct multiplication symbols here. So you should never use the star symbol in a mathematical assignment. It's a huge no-no. We don't use star from the keyboard. This is a legacy issue from when we only had 127 characters on a computer. An 8-bit computer from the 70s and 80s only had 127 characters. They had to decide which characters to use and include. They didn't include all of them, so star was used back then. We don't use star in computing in order to do multiplication, but not in mathematics. It needs to be cross or dot multiplication. Some things that you won't find in here. So Microsoft Word is much better than Google Docs when it comes to the equation editor and things you'll find. But you will find the implication symbol here, so you can do this one correctly. If there are bits and pieces that are missing, such as it's really easy to find them in Microsoft Word, to find like the double stroke characters for integer, real, complex numbers, and those type of things. You can find some other things by going insert, special character, and just draw the symbol if necessary. Oops, see if it finds it. Had a good go at finding it. Doesn't have a great one in this one. But if you want to find other symbols, like the degree symbol, you'll find it this way. Or you can type the keyword here. And it will pop. You'll probably find the thing that you want to add if you can't find it. So all your math needs to be written in the equation editor. Obvious things like it should be a professional looking font, no Comic Sans or Brooklyn Bold and silly things like that. Your body text should be in a size 11 or 12. Your title should be in a 14 or 25. If you have a cover page, you can go quite a bit larger on your title there, and so on. So that's it. I don't want to waffle on any more than that. You need to show Apollonius' method working for a particular point. You then need to show it working in the general form. So you need to do this general investigation and use your mathematical communication for that. All right, that's it.